Başladım. Okay. Our broadcast live started. Now I will give to my chair to Sevda for moderation, and I will give my chair to Wanda, Massimiliano. Our broadcast live started. Now I will give to my chair to Sevda. Okay.
Okay, as you understood that he is very sorry to lose his chair.
Yeah.
Yeah.
I am very sorry.
So for a while we are together, my friends. First of all, welcome all of the audience to join us, and also welcome to our important guest to join with us. Okay. Today the fourth of the day on Thursday, and it's very important day for us and for the blind community in our country. Why it is important? Because today we have four important guests here, and they are very, very, very important people in science. Let me a little bit introduce myself, then I will give words to my guests, and we will continue our presentation. So my name is Sevda Bozbey. I graduated from Boğaziçi University in the counseling department, and I completed my master degree in management and working psychology, and I'm also going on my other master degree in human rights in law. I'm in the thesis statement, and I am the member of Barrier Free Access, and this is our festival. This festival will be done the 7th times, and this is the festival. This is the seminar for our White Cane and Accessibility Festival. So these information actually are for our guest. So first of all, I want to introduce to our audience Wanda Diaz, Francesco Renzo, Beatriz Garcia, and also Massimiliano Razzano. You are all welcome again to our sessions and our seminars. Have a good luck, have a good presentation. I would like to remind something to you, my friends. These are the things if you have any questions, please raise your hand, and our co-hosts, our co-assistants will be take note. And after the presentation, we will ask the specific question to our guests. Okay? So first of all, we will make presentation, then we will arrange the questions together, and we will use the time appropriate. That's okay. So here we have four guests. This is Wanda Diaz, and as I said, Massimiliano Razzano and Beatriz Garcia and Francesco Renzo. But we have four Beatrices at the beginning. So Wanda, can you please introduce yourself and, if you like, your friends? Welcome again.
Hi, good morning.
Good morning.
Sorry, I was playing some sounds and I had to turn them off. I do apologize. Hi, good morning. First, I want to say thank you. I'm very happy to be here with you, talking to you. I get especially a lot of emotion and happiness come to me when I present to foundations like yours. And when I hear your shining voices.
Thank you so much.
I especially talk and address, right? Those that work really hard. And like me, I work a lot, and in very rare occasions, I got the expected results, right?
Yeah.
So I talk to everyone, but mostly to the people that work really, really, really hard. And it takes us a little bit longer right? To get to our results, and especially the students, if we have any in the audience, in the audience today. In the middle of everything that is happening, you have doing this meeting, you have taken the future in your hands. Sevda, Engin, the team, your foundation. And I'm sure that through this meeting, your foundation will prepare a new culture of scientists.
Yeah.
And in the next step you make, just as we are, just as we function with our diversities, will be vital in the direction of science and in the direction of society. To tell you a little bit about me,
Yeah.
As Sevda kindly said, my name is Wanda. I'm from Puerto Rico, which is an island located in the Caribbean region of the world. It's always warm, and so I lost my sight due to severe degenerative diabetic retinopathy. I have been alive for a long time, so I will not tell you about my childhood, etc. I will tell you that through a lot of work, I was able to achieve my goal of becoming a scientist, and I enclose that word inside quotes, right? Do you know what an internship is?
Yeah.
An internship, and thank you for saying that you know what it is. An internship is a short experience, a short work experience for you to acquire some kind of skill or experience for you to go into transition into the real workforce. When I did my first one, that was many months ago. Many months ago. So I had only 5% of peripheral vision in my right eye. My retina detached completely from my left eye, and at that time I only had 5% of peripheral vision. So that means that the center of the visual field is dark, and I would only perceive light and some shadows on the periphery, on the side of the visual field. During the day, I was able to orientate a little bit, but then during sundown, I was totally blind. But that was many years ago. Now I need my white cane, which I appreciate that I have it. At that moment, I did not have access to specialized professionals or specialized schools in my country to help me in the process. There is nothing wrong with that, right? I also tried to hide that I was losing my sight. At the back of my head, I didn't want to trouble my mom. She was working really hard for us to have what we needed to survive, and telling her that I couldn't see her face, right? That I could see her hands moving, but I couldn't see her face. That would bring a lot of weariness to her. So I was trying to hide it. The experience in the classroom at university, it was very bad. In university, at least in my country, it's very rare to find a lecturer who has taken at least one pedagogy, or who knows how to teach people with disabilities. So it was horrible. My lecturers will not adapt the lessons, and for me to understand the mathematics, I wanted to be a scientist, but the mathematics, I wouldn't understand it. And I wouldn't allow the scientific practices of that time, right? To the scientific discourse of that time to dissuade me. You have the benefit now of technology and the humanistic practices. Pedagogists are better prepared. We have scientists like Massimiliano and Beatrice and Francesco, who knows the pedagogy, and they know how to adapt lessons for people with disabilities. Before, that didn't exist, right? So I encourage you to always be grateful of that. I was living in an area in Puerto Rico. I was in university, and we were living in an area in Puerto Rico that began as an informal settlement. Now it is not, because we, the people, we chose, we were the ones choosing to use civil disobedience to convince the government to sell the land to us at affordable price, but we chose. At that moment, because of the way educational methods were structured, I didn't have many options. It was almost hindering my opportunity to choose, to use my right to choose what I wanted to do in life, and I wanted to be a scientist. To give you an idea, even beginning at university, I didn't know that astronomy was a career path. I would play with my sister in her room when I was a child about being an astronaut, because this is what we saw on TV. Star Trek, that's a TV series of some people flying in space, etc. And she was bedbounded. So to me, she looked like an astronaut bounded to that bed with a white blanket on top of her. But to me, the people on the TV were a bunch of white people floating in the sky. I didn't know that this was a career. In the classroom, in the university, it was really terrible. You went to university and you took mathematics in the university, but I will tell you how it was when I was in Puerto Rico, and I hope this has changed, right?
Sure.
So I would bring a recorder to the classroom. I would bring a recorder, and upon playback at home, the sound would be, do you hear this sound I'm making on the computer?
Yeah.
Do you hear it?
Yeah.
So the upon playback at home, this is what I would hear. If you place this over here and you substitute in this equation and you solve this side, the solution will be like this. So upon playback at home, the only thing that would make sense to me was the sound of the chalk on the blackboard. I mean, I hope now researchers in universities, they are being obligated to take some pedagogies, right? And some special needs seminars. So I remember that I got paired to a mentor who was using sound. He wanted to use sound to familiarize. And I'm using the word familiarize because this is what my project was. He wanted to familiarize the blind people with the measurements that were saved in the database of his space organization. He had been flirting with that idea, but he hadn't made a move. I knew nothing of space science, coding, astronomy, you name it. At that time, we didn't have a way to make that knowledge accessible to me. And I didn't have the money or the resources. So the first day of my internship, I went running to him. He said, "Hi, my name is Bobby," and my legs were shaking. I reached out for him. I found his arm. I grabbed his hand, and I said, his name was Bobby Candy, and I said, "Mr. Candy, I have to be honest. I do not know any space science. My math skills are very poor. My grades are horrible. I do not know what I'm doing here. I do not even understand what the other students are talking about. They say words that I have never heard. And when I hear them, I cannot even imagine how those words are written. I work a lot. And I do not know if I can have a project at the end of, if I can have a result at the end of these 2 months. And his answer was, "Don't worry, because I'm not worried." And I took that as an act of confidence, right? He told me that, like, "Don't worry, I'm not worried at all." So I began working, and I had this guy sitting beside me writing code to create an application that will translate the measurements acquired by the satellites into, into audio. And I was sitting by his side while he was working, and he would ask me to test his implementations, if his implementations were okay or not. And I said, this is not happening, because once they wanted to do this for all the blind people, and I do not represent all the blind people in the world. I'm only one person, Wanda. And if I wanted to be a scientist, I needed to learn how to explore. I needed to have access to the same amount and quality of information my peers had, and be able to perform the same tasks they were performing, not to sit there for that gentleman to be able to check out if I could find a button or not. So at that moment, that's when you say, this is up to me. And I need to take advantage, right, of the fact that this guy has me here, and this gentleman has me here, and I have the opportunity to transform this. So how do I get more than familiarization with the data, working really hard? I wouldn't socialize. I wouldn't socialize. I wouldn't go out. I would arrive to the office very, very, very early. I would leave very, very, very late, taking advantage that he had me there. That even though my mentor did not literally express the point of getting people, blind or visually impaired people, or people with disabilities in general, right, of getting people like me to do data exploration or mainstream, I knew that in his heart, he had a sense of possibility. He didn't tell me to leave. He said, finish your internship. So at the end of the internship, I published my first scientific publication on gamma ray burst, gamma ray emissions. And gamma ray emissions are the strongest explosions in the universe, which happen at the end of the life of a star that is very, very, very, very massive. We call that supermassive star. And believe me, I didn't know what gamma ray bursts were when I arrived there. I even didn't know that a star is a ball of hot gases. What he did was that no question was dumb for him. He and his wife would spend sometimes until midnight getting me through the mathematics. They made me feel appreciated. That's why I strongly oppose those who say, if you cannot learn it in this way or do it this fast, you were not born for this. And that is very common. You find it in places, right? Not where I perform. I'm anchored in the fact that if you have the determination and the dedication, you were born to do it, even if it takes you a lifetime. Time is eternal. Don't worry about time. Time is eternal. That also bolds and underlines something that I always say that is from the Human Development Report. That is that in the extent that we give people the opportunity to use their skills, acquire and use new skills, their enterprising spirit will grow stronger. What we need to give people is the opportunity just as they are. So after that first internship, my mentor brought me to his space agency for 10 summers in a row. So for 11 years, I kept going to his space agency. And I'm very humbled to say that my experience with him was documented as an unprecedented case of mentor and disciple. Just because he gave me the chance. Because he didn't care about my grades. He and his wife focused on my interest. So I use as a computing scientist and an astrophysicist, I did a PhD in computing science at the University of Glasgow. It's computing science and astrophysics is an interdisciplinary PhD. So that means two departments together, supervising my doctoral research. And what I did is that I focused on using sound to analyze the measurements acquired by by telescopes and satellites orbiting Earth. Why I use sound? One reason has to do with my own sensitivities. Because I'm diabetic since I was a child, I suffer of touch hypersensitivity. Don't touch me. Don't touch me. I'm a judo wrestler. I'm an Olympic wrestler too. I'm also very big. And when people touch me, I may not respond very well. And I want to have friends. I do not want to be feared, right? So I don't want to use my judo. Don't touch me, talk to me. Other people like touch, and that is very great. Also, when I was doing my doctorate, we did experiments at a university in Massachusetts, which kindly also supervised my PhD. We did experiments at a university in Massachusetts called Harvard, where I'm working now, and we evidenced that when you use sound, it increases your sensitivity to important things in the astronomy information that by nature will be blind to the human eye. And at that moment we said, what? Why these very smart scientists stopped using it if it makes the analysis of data more effective? Because they are very smart. We thought they already had evidence that sound would worsen the data analysis. And what we found was contrary to that. Sound increases your sensitivity and improves your identification of events in the data. Another reason for me to use sound is that dealing with sound provides me for me to interact dynamically with the measurements. For example, some space scientists, not all of them, and astronomers apply mathematical states dynamically to the information. They carry a perceptual task, usually with their eyes, and after carrying that perceptual task, they decide what mathematical analysis or what they will do to analyze the data. Using sound allows me to use it dynamically and very fast, and not to have to wait to emboss the data or 3D print it, right? Perhaps you are familiarized, perhaps, that some telescopes, or many telescopes, or most telescopes, I don't know how to say it, try to compile information that is invisible to the eye, in the form of invisible light. And as you may already know, most of the light known by humans is invisible to the eye. Some things that I study are the energy from the sun, and the effect of that energy on a region around our planet and around any astronomical object called the magnetosphere. I also, as I said, study the more energetic events known as gamma ray bursts, which is another form of light or energy known to humans. And I study symbiotic stars, which, as you may already know, are, in my case, in the case of my system, is a system of two stars orbiting a common point. And these two stars, in the case of the symbiotic system, is symbiotic because they have a kind of an interaction, right? In the case of the two stars that have that interaction, that are symbiotic, that I study, they both are almost at the end of their life, and they are a white dwarf and a red giant. Let me see. A star like our sun. They emit energy because they are fusing hydrogen, right, inside of their core into helium, and that is what our sun is doing right now. And we get amazing heat. If you live in the Caribbean, you can go to the beach 365 days of the year. If you live in Colorado, where I am right now, well, the sun is like painted in the sky, but it doesn't have, it has nothing to do with the amount of energy emerging from it. It's because it's winter here in this side of the, the heat the sun generates by that fusion, the nuclear fusion of hydrogen into helium, creates an outward pressure. At some point, that source of energy, that fusion, you know, the amount of fuel that it has in its core, it will run out. The situation, so is the hydrogen fuses, I will use that word, I don't know if that word exists, fuses, and it causes for radiation to go to emerge, right, from the core. Other processes happen in there, right? So it's not like instantly. It takes a while, and then that energy causes a balance, a thermodynamic balance in the sun that keeps it as it is right now, in balance. It is like pressure, like a pressure cooker. I don't know if you know that a pressure cooker is a container sealed, and then you seal it and then you heat it. And then when you heat something in a pressure cooker, it causes a buildup of pressure. So it's similar to that in the buildup of pressure in the sun. But the sun is not a sealed container, right? Gravity, which is increasing in the center, causes it to pull also inwards, while the pressure created by the hot, I would call it hot gas in the core, is pushing outside, and it creates a balance. So there is a pulling inwards and a pushing outwards. At some point, the star runs out of the fuel, which is hydrogen, and there is not so much pressure outward, and the balance goes towards, it favors more the pulling of gravity, and then the star starts to collapse, and it starts to get compacting. Well, Beatrice and the others will correct my wording, but that compacting, it causes it starts to collapse, right? And she begins to compact, and then that compacting causes it to heat up again, and she's able to then fuse perhaps some hydrogen that is remaining in the surrounding, right? In the surrounding shells are wrapped around the core, and this area that is this burning shell will expand, and will expand the outer layers of the star. And when that happens, it becomes a red giant. And my system, as I said, is a white dwarf and a red giant. So that is how a red giant forms. But after that expansion happens, it will, the red giant continues eating up, right, elements, for example, the helium that is produced in the center, and producing other things. And when that, the material that she has is finished, it won't be like, what she has, it would not be enough to ignite what she has in the core. And she succumbs to gravity again. And when that core of the star contracts, it will cause a release of energy that will again cause the envelope of the star to to expand, and she becomes bigger than before. And then this continues happening until the star finally blows the outer layers that she was burning, until she blows those outer layers off. And she blows off outer layers, but the core of the star remains there. I will not say intact, it will remain there. And she becomes a white dwarf. So in my system is a red giant. So it's one stage of stellar evolution at the end of, and then a white dwarf.
Mm-hmm, mm-hmm.
So what I find useful for my ways of exploring the measurements is that when these waves, which is, we call it electromagnetic waves, an electromagnetic wave starts with a charged particle. This particle creates an electric field that creates a force on other particles. And as the particle is accelerating, it moves in its electric field, which produces a magnetic field. And the electric and magnetic fields created by that particle will enrich each other. I call that self-perpetuating, right? That means that an electric field that oscillates as a function of time will produce a magnetic field and vice versa. So what I find useful is that those waves, they spread. And when they spread, they propagate. And when they propagate through a medium that fluctuates or it's random in its composition, the waves that travel through the medium as they interact with the different fluctuations, the different, fluctuations in the media, they change direction, they are reflected, they are bented. I don't know how to say that word in English, I do apologize. They may become more tenuous, and more things. And according to that interaction, according to the light changes that we can receive in the satellites and satellites and telescopes, astronomers can deduce what is happening in the media. The light, I don't know. So we call observing, right? How the light was bended, reflected, the intensities of the light, listening to descending tones. We call this as a change in the refractive index. That means how the flow of that energy is changing as it passes through the different conditions in the media, how it interacts within the media. And studying that refractive index, or how that energy changes, right? As it travels through the media and interacts with other things, other particles, dust, magnetic fields. It may, for example, accelerate other energetic particles that you can conclude things about, like electrons, etc. Those fluctuations will result in changes in wave characteristics, like amplitudes, or how high the wave is, and frequency, or how many times an oscillation repeats, etc. And those amplitudes and those frequencies, those changes in waveform, right? Even a phase change are easily perceptible with the ear. So we guess that it was possible to hear those modulation of waves traveling through the media. And we guess that was possible to hear with a trained ear by listening to the amplitude of the emission or power, the amplitude or power of each signal and its frequency. And in physics, in astronomy, we call that a power spectra. The power spectra then is the amplitude, the power of a signal related to its frequency, and how that power or amplitudes are distributed over frequency. Sensorially, it sounds like many ups and downs, or
Yes,
think of right, or
Yeah.
think of a hairbrush.
Yeah.
If you grab a hairbrush and touch the filaments, put it horizontal, and touch the filaments from left to right, or right to left, and imagine that some of those filaments are a little bit lower or higher inside that sea of filaments. It will be hard to perceive by the eye. For a person like me, it will be very, very, very bothersome to touch it. But if I do it with sound, I can modulate, right? I can modulate the sound to my perceptual modalities to make it comfortable for me, and be able to perceive any slight changes that may or may not be of importance for the analysis. So we heard that power spectra I just described, focusing on any low frequency variations that may happen in the measurements.
Just a second, please. I'm so sorry. If you like, the translator will change because Şebnem is tired of maybe.
Yes, yes.
I'm so sorry, Vanda. Şebnem?
Ya Şebnem vardı.
Faruk'cum alır mısın?
Almıştı yani.
Okay, that's okay. You can go on, Vanda. But Vanda, you are talking about totally different and stranger things, imaginary things for our community. Thank you for your fantastic presentation.
Thank
Really.
you.
Yeah.
So we heard the data.
Yeah.
And to focus on small changes, and in the data, focusing on that on how the flux was changing as it passed through the media. And now I want you to listen to a sudden mass ejection from the sun. This is an example of an spectral index, right? What I did. This kind of ejection from the sun is called a coronal mass ejection. It's an event in which a huge amount of energetic and highly magnetized gas, ionized gas, energized gas, is ejected from the sun into space. So this the shock is ejected from the sun, travels through the space within the planets, and what you will hear to the power spectra, right? This is not the data as the shock arrived to the satellite, but you will hear the power spectra. And what I'm going to do is to play. To play 10 seconds of the data, and what you will hear is some descending tones, meaning that the power spectra is descending, and the media is getting more turbulent. And we will only hear 10 seconds of it. I apologize. I have to turn off the heater, and I hope you can hear it.
Okay.
I don't think you can hear it, right?
No.
Vanda,
Can you
Vanda,
share your screen? Can you share your screen, Vanda?
I think we can now hear.
Yes, we can. Yes, I think we can now hear. We can hear.
You can hear. Okay.
Yes.
It's very low. There.
No, I think no, Wanda. Can you share your screen better?
Vanda, you should say into the chair sound also.
So you will hear. It's wood blocks sound. It's not a bumblebee. It's wood blocks sound, and it will go in the sound of wood blocks. It will sound like. and then it will increase a little bit. I can send you the sounds because I want to finish. So Beatrice and Francesco and Massimiliano can. So what it means is that the media is becoming more turbulent. Like I'm a particle, and you all in Turkey start running towards me, and I'm there by myself, and then you crash on me, right? It's not going to happen that easy, because I will exert some opposition to your movement, regardless how small am I, right? So also all of those interactions, I found that it was possible to hear it in the data as the collision energizes the media, and it energizes me, and there is an exchange of energy in between the particles, and that is the way that I got to be able to mainstream. Supporting my ways of performing to characterize the local behavior of those particles, right, in the interaction. In this case, right, the interaction of the particles in the media and perhaps particle wave interactions, and we give that names like cascade mechanisms. But I do not know, right, if this is finding turbulence in the interstellar media is important, especially when the solar wind is quiet and when there is no huge emissions of energy from the sun. I really do not know. The only thing I know is that this kind of phenomena, right, called turbulence, is kind of a complex thing that I may help to characterize, right? And that empowers me to continue finding ways to continue using sound to analyze data. Before I finish and pass it to Beatrice and to Massimiliano and Francesco, who has a very good presentation, and they have been working for equal participation for a long time, especially Beatrice. Thank you for this conference. For taking the future in your hands.
So Wanda, thank you.
Yes,
thank you for your presentation. And we will have some question after all the presentation have been completed, okay? So
yes.
Wanda, are you unique in the world in this science?
No.
Is it blind?
There is late onset, there are late onset blind people. It means that they were sighted, right? And they were already at the top of their careers. Early onset blind people, we do not have any, and we need to change that.
Yes, we change. Okay, thank you for your fantastic presentation.
Thank you.
So Beatrice, hello again and welcome. First of all, I need to actually introduce, I need your introducing, and then after the introducing, you can go on
I
presentation.
think Massimiliano and Francesco need to be first. Yes.
Yes. Professor Razzano, welcome again.
Hi, thank you very much. Sorry for scrambling the agenda.
No problem.
Thank you very much. So thank you also to Wanda to let us pass earlier. So first of all, thank you very much for the invitation. It's a great pleasure to be here. So let me put on the video so that I can say hi. Today I'm gonna just give you a very, very short introduction about the importance of gravitational waves, because after me, Francesco will talk about what we are doing in terms of increasing the awareness for science, for the science of gravitational waves, and raise also the inclusiveness for all the projects that we have within Rainforest. So Wanda has explained and give you a very, very interesting introduction about what we are looking into sky. So why this is so important. And as you know, recently in these past years, we have opened a whole new windows on the universe, which is the window of gravitational waves. And why these are so important? Well, actually, because they are giving us a new new sense, a new way of looking at the universe. So gravitational waves are being predicted more than a century ago by Albert Einstein in his theory of general relativity, which was basically a theory of gravity, an improvement of the theory of gravity. And more recently, and people took like 100 of years in order to detect these things. Einstein itself was saying that this was very, very hard to detect. And initially, he had even some doubts that these gravitational waves even existed, right? So why these are so important? So let me also introduce my background, because I started working on gravitational waves in these last years, because before I was working on astrophysics, but on high energy astrophysics mostly, which are basically studying the most energetic sources in the universe through X-rays, gamma rays, emission, and then when I came, I studied in Pisa. Then I spent some time abroad, and when I come back to Pisa, I started joining this experiment, which is called Virgo. And Virgo is one of the 3 main detectors for gravitational waves that are in the whole world. Recently, there is a new detector called Kagra in Japan that has joined this international network. And in 2015, we first detect a first signal coming from the fusion of 2 black holes. We call this phenomena coalescence, which means that we have 2 black holes that are spiraling and then are merging one into each other. And this is very important because from this event we can learn a lot in terms of the physics of the strongest gravitational fields in the universe. So that's why people are so interested in gravitational waves, because using gravitational waves you can do things that usually you cannot do in your lab, which is building a black hole or something like that. This is something that you don't want to do at your place, right? So in this way, we're going to study the most extreme sources in the universe, and that's why people are so interested in that. So so what we're doing now is trying to, we're doing a lot of public outreach, so trying to communicate to the people, to all the people, what we're doing and our discoveries, our research. So recently we published a new catalog that contains 50 gravitational wave signals. And the very nice thing is that we have a very huge activity in, as I was saying, in order to bring the discoveries to the whole world, to the whole people. And so this is the reason why we join our forces into this project called Reinforce. And this is a European project, European-founded project that contains different aspects, not only gravitational waves, there is also neutrinos, particle physics, etc. And now Francesco will show you some more specific details about what we're doing. And the idea is to build a project that will involve people all around the world that will be able to join us and to help us in the study of what we call the noise and the background noise. And this is very important because when you want to see a gravitational wave, its effect is very tiny. So every time a gravitational wave passes through our detector, this very long detector will stretch by a little bit, and by a little bit I mean 1,000th of the size of a proton. So it's very small, like what we call 10 to the minus 18 meters. So a billionth of a meter. So it's very tiny. However, we can do it, and the problem is that we have this very tiny signal is immersed in a very high background noise, which is everything else, like the seismic motion of the ground, the turbulence in the atmosphere, and other stuff like that. So we want to be able to distinguish between the noise and the real sound and the real detection. So this is what we're doing now with this project that we are putting together. And of course, a very important part is related to the sonification. So Wanda's already talked. Beatrice was also we will also talk about this. And now Francesco will show you in more detail what we're doing with some examples of our data. So I stop here. So I leave the floor to Francesco to give you more details.
Thank you. So welcome again, Francesco.
Hello, everyone. I hope
Hello.
you can hear me.
Yes, of course.
Yes.
Perfect. Well, first of all, thanks to Massimiliano for the introduction, and thanks to the organizer for inviting us to this event. I have some slides to share, but most importantly, I have some sound. I hope I will be able to show you at the end of this presentation.
Yes.
Okay. Well, as Massimiliano said, we are working to detect the gravitational waves as emitted by compact objects that coalesces. We have our detectors, which are some kind of antennas for these gravitational waves. As every antenna, these detectors are sensitive to the signal, to the gravitational waves that passes through the detector within a certain frequency range. In particular, this range is more or less between 20 Hz and 20,000 Hz. This is similar to the human hearing range, with just a small exception. That is, due to the noise that Massimiliano mentioned before, the region where our detectors are most sensitive is located more or less between 50 Hz and few hundred of Hertz, let's say 500 Hz, okay? So if we want to convert this frequency range to a sound, we will feel this as quite a low sound, okay? On the left-hand side of a piano, for example,
Okay.
while human hearing is most sensitive around, say, 1 kilohertz, more or less. And in particular, the conversation where the sound produced by my voice is located is from some 100 hertz to, let's say, 2 kilohertz or more for children, etc., and people with a very high voice. Okay, so this is to describe to you the parallelism between a gravitational wave antenna, like the Virgo detector, and our ears and human hearing. Okay, as I will show you in a moment, and probably most of you already know, there are gravitational wave signals produced by very, very fast, very transient events like the coalescence of two black holes, or in general, two compact stars. The corresponding signals last for a fraction of seconds. It depends on the total mass of the two objects, but the lower the mass, the longer the sound. For 2 neutron stars with 1.4 solar masses, the signal may last about 1 minute or 2 in the sensitivity band of our detector, while for more massive stars, just fraction of a second. Of course, as you can imagine, there are many other signals, not of astrophysical origins, that they are noises, and they can mask the signal that we want to detect. They can mask the astrophysical signal. So it is important to get rid of them from our detectors. That is, identify all of them, study when they happen, what's the reason, what are the causes that produces them, and finding the causes and acting on these causes, we can have better detectors for the future and detect more clearly more astrophysical signal. For example, the most noticeable noises of this kind, which are called glitches, the most noticeable glitches was the one happened during the gravitational wave event called 1708-17. This was the coalescence, the very first detected coalescence of two neutron stars happened in August 2017. And in one detector, in Livingston detector in the United States, in correspondence of the event, there was one of these disturbances, one glitch, which overlapped with the gravitational signal. This made its identification quite difficult and required some specific analysis. This justifies what I said before, that is, we eventually want some detectors that have the least number of these glitches as possible, to have our gravitational signal the most clean that we can have. Okay. And in the remaining of my presentation, I will show you how to distinguish glitches, that is noise, transient noise, from transient gravitational wave signals. Also, I hope that at the end of my presentation, I will be able to share with you some sounds of gravitational wave signals and noises. And I expect from you that you will be able to distinguish the two. Okay. To make this distinction, we have in mind to involve citizens, because, as I just said, if I sonify the signal corresponding to a gravitational wave event and that of a glitch, they sound really different. Like a duck produces a sound different from a rabbit or from a porcupine or whatever. So people with their ears are able by nature to distinguish them. Also, looking at how they may be represented in a time frequency map, like a spectrogram, as Wanda said, or from their sound. They sound really different, like different animals have different sounds. Okay, so our idea is to merge these two aspects, the visual shape, the visual aspect of how a glitch and a gravitational wave looks, and the sound associated to them, and make people able to distinguish them. After that, since we have a huge amount of data and not that many people willing to contribute, or I mean, it can be boring at a certain point. We want to teach a computer to do the same distinction, to be able to distinguish what I call the glitches, these noises, and gravitational wave signal. This is the goal of our project. Our project, as I said, it is part of the Rainforest project of the European Union, and it will be hosted on the Zooniverse platform. Okay, so for next spring, for spring 2021, we will list this website and about this classification project, where people are asked from visual input and an audio input to distinguish between the two signals that I described before.
Is it accessible for everyone on your website?
It's going to be accessible for everyone, of course, and we really need the help from everyone. As I said, it will be launched in next spring, so spring 2021.
Of course.
For now, we have developed a demonstrator. We are gathering feedback. We are working to improve it. And this is the end of my presentation. What I wanted to show with you now is the sound that I've mentioned before. I am quite new to Zoom, so please tell me if you're able to listen to.
You can share, I think, your screen. You can share your screen. Then you can, if you like, you can share your sound. If I'm not wrong.
I'm trying to play the sound. Tell me if you are able to listen to something.
Okay.
Okay, play.
Did you hear that?
No.
No.
But, okay,
No.
let me try
Francesca,
again.
Francesca, stop sharing firstly.
Stop
Ah,
sharing.
okay.
Then, by sharing, you should set sound also. Before
Perfect.
starting to sharing, you should choose sound, include sound also.
Okay, now I'm
Share
sharing
computer,
computer
you should
sound.
choose share computer sound, yeah.
Okay, let me try again.
Okay. That's okay.
Okay,
So we
Yes.
can hear.
did you hear that?
Yes, we can hear now.
Yeah.
Yeah.
Okay, nice. How would you describe that sound? If you want, I can replay it.
Please. Oh.
The piano.
It is a piano, great.
Multiple voice piano.
If you had a piano in front of you, you will be able to reproduce that, to reproduce it, or attempt to at least. Well, still, not important. Let me reproduce another sound. Okay, did you listen to it?
Yes.
Perfect. Okay, it's not me playing, of course. These are audio track obtained from signals of various types. Okay, and let me tell that the first signal, the first audio that you have listened to, is a gravitational wave signal, and you maybe have noticed the ascending scale that is from lower sound to higher sound, and also higher notes are played more closely one to each other, more or less all together at the end. Okay. Instead, the last sound that I played, this one,
Oh.
these are these are notes from the left hand side of the piano played in a sort of confusing way. I mean, they don't have an ascending pitch. They are kind of random low noise sounds. Let me play another one. Same thing, but at higher pitch. These are higher notes. The notes follow one each other in a kind of random way. And as I said, this again is a glitch. Okay, more or less random sounds following each other, while the very first sound that I've shown to you is increasing pitch with the time. It's called a chirp, like the chirp of a bird. Okay.
Okay,
I ask it to you.
how can you discriminate? These are actually you are specialized. I'm so sorry for this bad question, but how can you discriminate these are the real voices, that these are the unnecessary voices? These are about the gravity. These are not.
Well, I guess that you can tell the difference between the three sounds that I've showed to you. The first sound, the one associated to gravitational wave, is one note followed another one with an higher pitch, another one another pitch, another one. There is a sequence of notes with higher pitch, with higher and higher pitch. Okay, one note is more is higher than the previous one. It's like if you have a piano in front of you and you play a key and you move your finger to the right. Okay, the same. You are able to reproduce this sound doing as I told to you. Press one key in the piano and move your finger to the right. This is the sound expected, more or less, for a gravitational wave signal. Instead, the other sounds are from glitches, and these sounds are like you press one key, you press another key which is not related to the previous one, you press another key more or less like that. It's more randomic. Okay. Glitches as this
Yeah,
behavior more or less to be more randomic than gravitational wave signals, which are described by equation, the equation of general relativity. So for this reason, we are able to distinguish gravitational wave signals clearly described by one equation, distinguish it from random noises. Okay.
One of our panelists say that could you please play the first one again?
Sure. And imagine a piano in front of you. Okay.
It's the gravitation wave.
Yes.
Because
Yes.
it's coming from lower to higher. Is it true?
Yes.
Yes.
And could you play the other one, which is the glitch one?
Sure.
It's randomly.
You may have heard several notes. One higher one. I mean, the sequence of notes is more randomic in this case. This was the example with low frequency notes, and this is the example with high frequency notes. This is like you are touching the piano, but you are not really knowing what you are doing. It's like you touch and you are kind of afraid. You touch again in a random way. You don't want to play anything meaningful.
Yeah.
This is a glitch. And let me play the last sound. Also, this one is randomic. Someone is playing, hesitating, one side of the piano, another side of the piano, without knowing what to actually do, what to actually expect. And again, this is a glitch. So I guess that now, with my explanation and with these examples, you are able to distinguish between gravitational wave signals and glitches, right?
Yeah.
Yes, of course.
Of course, you need practice, as everybody does.
More practice.
Sure. And this is what we want to provide to you, starting from spring, next spring. Give it to you a huge database. I mean, we have a lot of gravitational wave signal. We have a lot of data.
Yes, we can keep in touch about your website and the progress.
Sure. And associated to each of these data, there is a sound, there is an image. You can play both and try to distinguish, to discriminate between what we have found. Also, let me introduce this. As I said, the sound of gravitational wave signal, the duration of gravitational wave signal varies with the mass of the two stars emerging. The higher the mass, the faster the sound, but also the pitch is quite lower. Instead, for two low mass stars, like two neutron stars, the sound lasts much more, and the pitch is higher. The final pitch is higher. So from this description, you should be able to make a guess on the masses of the two objects, the total mass. In the sense, if you listen to a sound which is very fast, like the one that I played 1 minute ago, you can tell, okay, this is quite a high mass. Instead, if I play a sound which is very slowly increasing in its pitch, then you can tell, okay, yeah, slowly increasing the pitch, then you can tell that these are probably two neutron stars or two black holes with low mass. well, that's our purpose for you.
Okay. Mhm.
And well, that's all I wanted to show. I'm happy that I was able to share the audio. Start sharing now. Okay, do you have any question? Or
we will-
otherwise, leave the floor to.
We will get question after the presentations. All the presentation has been completed. So before
Okay, so-
Kaan, Beatrice, would you like to change the translator? Faruk'cum devam etmek ister misin? Okay.
Yes, of
Our
course.
translator.
Sevda konuklar görünmüyormuş ekranda. Şimdi gördüm ama galiba videolarını açmalarını söyledi.
Can you please turn on your video show because you were not seen on the screen.
My video, my screen.
Okay, yes, panelist. I mean,
Your
Beatrice.
camera, Beatrice.
As panelists. Oh well. It's too. Yes, sorry, it's too dark because I never use the lights in my house. Excuse me. Wait a minute.
Yes, of course. Faruk'cum istersen Şebnem aldı istiyorsan.
Well, now I'm here. Sorry, because it's too cloudy here. It's completely dark, and I have not lights on.
Okay. Şu anda just a minute please.
Okay.
Arkadaşlar şu an görebiliyor musunuz konuşmacıları?
Ben şimdi klavyeye baktım.
Evet, görebiliyoruz.
Okay. So Beatrice, thank you. Go on, please. First of all, introduce yourself, and then you can go on your presentation, please.
Yes, of course. Thank you very much for the invitation, and thank you very much, Wanda, who is the person who introduced herself to you. I'm an astronomer. At the beginning of my career, I studied open clusters and stars. So an astronomer devoted to study the visible part of the spectrum. But now I move a little to the other energies who cannot see the human being. And for this reason, I have some experience with these regions of the spectrum that the most part of the people cannot see. I will share my screen just to have my talk because I have approximation, the visual approximation to the nature. So as Massimiliano and Francesco mentioned, we are working in a very big project with people to make science. And the idea is to give the tools and resources to permit all the people to make science, not only those people with the visual approach to the knowledge, and to enlarge the capacities for the people who can see, because if you approach the nature, use all the senses, the knowledge is better. As you surely know, the astronomy and all the science as a professional field only really benefit the people with the performance styles currently available in the field. But our idea, we are convinced that anyone may develop a disability, as Wanda mentioned, and currently the population has not a real way to the real size. And for this reason, taking into account that the most part of almost all our knowledge about the universe and the nature arrives not from the visible region, but beyond the visible, and the astrophysics develop the multi-wavelength approach to the study of the light, and now the multi-messenger approach, which open a new window of cosmos using the data from cosmic rays, gravitational waves. The idea give a new step, a different approach, and produce something that we call multisensorial or multimodal astrophysics. Naturally, normally, the participation in the regular stream of performance has not been taken into account from the beginning in the agenda. So it appears that the international efforts are limited to developing packages and resources and all kinds of material that address the visualization, taking into account mainly in this moment the big data drives all the inclusive aspects of social development. We think that the big data and big science must be open to all the people, permitting to make a real change, a real contribution to science. For this reason, we are presenting now and in many other places a new approach to develop analysis and retrieval based in the first design. It means we don't produce what we want, but what the people need to make some user-centered design, user-centered approach. This kind of development needs a theoretical framework, and we base all on this framework established from the attention mechanism and coping strategies with visual disabilities, and we focus our improvements in the analysis of the results using and through the testing of the resources by focus groups. As you can imagine, this is not a work on one person, multidisciplinary, multi-layer approach, and integrates astronomers, engineers, design educators, ability specialists, psychologists, sociologists, and all these people is working. In these groups also participate both people, able and disabled. So it's a really challenge development. What we consider at the beginning for the development, for the new design, well, that all the resources must be accessible, and the accessibility must be also to the scientific data. The data can come from Earth or instrument on board in satellites, as Wanda mentioned at the beginning. We need to test the efficiency, the usefulness, the effectiveness of the resources, not only one group, but with different cultural sense. And the goal is the creation of a human-computer interface suitable for access, collection, sonification, and analysis of astrophysical data. This development is called Sono 1. It's a software user design, and which use the sound as complement of visualization. It means it is a good resource not only for blind people, which are ready to use other senses, not only the eyes, not only the visualization, but also the sonification. This new approach permits to combine accessible features with the scientific efficiency, and is completely open source, cross-platform, can be used in any kind of computer, and so can be recognized all the resources.
I'm so sorry.
By the screen readers. We are sure that this kind of allows to improve the work with different styles of data exploration. It's not only for the people which with a special approach to the data. No, it's for everyone.
Beatrice, excuse me, can you a little bit get away from a microphone? A little bit.
So, sorry?
Yeah, could you please a little bit get away from your microphone? A little bit.
Yeah, yeah.
Here is better.
No. Away. Not, don't approach.
Here is better.
Okay,
Yeah,
that's okay. I'm so sorry to bother you. I'm so sorry.
It's okay. Tell me when you cannot hear.
No, we can hear,
Fine.
but yeah, that's okay. Go on, please.
Okay. Well, the idea of the software, I can follow. Can I?
Yes,
Yeah,
of course.
yeah.
Go on, please. Of course.
Oh, okay. Well, the idea of this development to create a modular software which different kinds of through which you can plot the data, hear the data, manipulate the data using mathematical functions, as complex as you want, all at the same screen, and with the possibility to recognize each section of the software using a screen reader. The software permits the input of a large data sets, so it's useful, for example, to analyze gravitational waves, and use a particular sound synthesis model. Is not, for the moment, we don't use MIDI resources for. We synthesize the sound. We can manipulate the waveform and manage the sound in the better way for your personal perception. This new proposal permits to study any kind of data. It means you can use, for example, a large data set like the Sloan Sky Server, which is devoted to collect a great number of spectrum from galaxies. And, for example, the redshift for the galaxies. Use this resource to detect the arrival of cosmic rays, and you can use the data after the analysis, because the software permits to record and to save the sound, the data, and all the parameters that you introduce as mathematical functions in your data. I don't know if I can share the sound now, probably yes. Give me a moment, because I need that you, I need that you hear.
Sure.
This. Can you hear?
No.
Beatrice, please stop sharing firstly,
Okay.
and before starting sharing, you should share computer sound first, then start sharing.
Let's try, because it's a what is the problem? Sorry.
I think you don't share the computer sound, so we couldn't hear the sound. So before
Let's try again. Let's try again.
Starting sharing again. Be sure that you should share
Computer audio.
sound.
Yes.
Like Francesco did before.
Yes, I need to stop video, I think. And
Yeah, stop first the sharing.
Then
Now?
choose computer sound.
Text area. Nanos astronomical cosmic rays group 1 of 7. Galaxies
Is this screen reader?
Well, this is this is a reproduction
But,
of the light sound and the phenomenon in action.
Beatrice, did you share the screen again?
Yeah.
Okay.
Yes.
Okay, this is a mapping, the frequency mapping sonification of a very, very small set of gravitational waves data. This is the frequency mapping, and the next
Oh.
is the volume mapping, okay?
Uh-huh.
Yes, perfect. The next the next tool that we are preparing is a website. The website also is ready to reproduce anything that you want to reproduce. For example, I will share with you a small part of the one spectrum. The spectrum is a galaxy spectrum, and you will detect emission lines. Please let me know if you can hear.
Okay.
Oops.
We couldn't hear.
Yes, we can hear now.
Wait a minute, because I have an start. It's not a good connection. Not a good minute. Let's see again.
Yes.
Let's try. Okay. Here again. Oh, well, now it's raining.
Yeah.
No, I will try with another. Wait a minute.
Okay.
Did you hear the rain or on my own? Wait a minute. Here.
Yes.
Did you hear?
Yes, of course. Uh-huh.
Again.
This is different.
Well, these variations, these changes, is a galaxy emission lines. So it's possible to detect what kind of development is based in the exchange with the users to determine the new steps to follow. We change when the user change, and we need to confidence and freedom to the people to continue with the research career. In the future, we think that the nation will this kind of development and recognize even the scientists and the scientists recognize multi-sensorialization as a valid study of the data, and we will try to stimulate funding agencies to ensure that the proposal funded include people with disabilities and other diversities in this kind of role to the real participation in the scientific research. In the future, we also believe to increase the abilities to identify signatures in the information, as Francesco mentioned before, bring people with disabilities to the field of the science, increase the amount of the scientific discoveries, to enhancing the work of the scientists, accepting different data exploration styles and more perspectives and experiences. Because it is time to mainstream those that historically have been completely left out of the scientific research fields, increasing the enterprising spirit. This kind of approach will motivate merchants of a humanistic metric and a model of competition that will generate more inclusiveness. You know, we are talking almost all the time about equality. Well, equality is give the same tool to all the people. But it's not the equality, it's equity. And equity is give the tool, but the right tool to each person. Anyway, equity and equity are not enough. We need to give more opportunities. Wait a minute, because it's a big storm here.
If you like, we can change translator in this break.
Sorry. We are in the middle of a big said equality and equity are not enough. We need to eliminate the causes of the inequity. We need to remove the systemic barriers. And for this, we need to give everybody. Can you hear me? Yes.
Yes, we can
We
hear you.
need to eliminate the causes of the inequity. The idea is to open a new windows, a new door for the access to the information, the research, and the whole set of possibilities to everybody. Well, that's all. Thank you very much.
Thank you.
Thank you. Thank you.
Wanda, Francis, and Massimiliano. So, after maybe some questions.
Sevda, the sound is distorted. I think perhaps one of the assistants has the microphone unmuted.
Okay.
Okay. No.
Doğrudur.
Okay. Okay. Sudeciğim, arkadaşlar herhangi bir soru var mı bu arada bize iletmek isteyen? Sırayla, belli bir sırayla alabilir miyiz soru sırasına ve parmak kaldırma sırasına göre? So we have, I think we have some questions from coming from France. Yes. Gökçe'cim organize eder misin?
Ben bir soru gözükmüyor ama YouTube üzerinden de, chat üzerinden de.
Olur, o da olur.
Bir bakarsın.
Ben parmak kaldıramıyorum. Sorabilir miyim? Parmak kaldırma düğmesini bulamadım.
Sor abicim, sor.
Yani normalde hani parmak kaldırmak gerekiyor. Onu biliyorum ama düğmeyi bulamadım.
Devam edebilir misin?
Şu an sesim geliyor mu?
Yaklaşır mısın ablacığım? Evet.
Peki birincisi şeyi soracağım. Uzaya gitmek gibi bir hayalleri var mı? Hani astronotlar ya kendileri. Yani bu noktada şey yapabildiler mi? İkincisi yer çekimi dalgaları demişlerdi. Bu dalgalardan teknolojide istifade etmekle alakalı bir çalışmaları var mı? Yani mesela işte ses dalgalarının daha böyle iyi yayınlanması, ne bileyim kablosuz sinyalin ya da Wi-Fi dediğimiz teknolojinin daha iyi çalışmasıyla alakalı, hani yer çekimi dalgalarından faydalanmasıyla alakalı bir çalışma söz konusu mu? Yani bu yer çekimi dalgalarının günlük hayatımızda kullanılmasıyla alakalı soruyorum. Yani teknoloji vasıtasıyla tabii.
Teşekkür ederim. Okay, Wanda, we have Wanda, Beatrice, and all of friends. We have two questions. The first one, do you imagine to go to space as a blind? The first question is. And the second question, can you also facilitate different technology for the gravitation waves?
Shall I take the first one? That's where we are going.
Yeah.
That's where we're going.
Yeah.
We are. That's exactly our work. The work Beatrice, Massimiliano, Francesco, Dr. Katsanevas are doing is a work of equality. So we will be in outer space. We will defeat the medical model of productivity and the economical model of productivity we have in science, and we will be there very soon.
Yeah.
Next year. Francesco, Beatrice, do you want to take the second one?
I think can you hear me?
It comes distorted, but we can hear you.
It's a storm. It's a terrible storm here, and I lost connection. It's better try to contact the International Space Station.
Okay.
It's terrible. Yeah, it's incredible. I'm a bit worried because the trees are touching my roof.
I hope you're not in danger.
Are you in danger?
Yes. Me too. Well, anyway, if you can't hear me,
Yeah, we can hear
I
you.
can say that we live in an amazing moment with all the opportunities to make a great science, even with different kinds of approach to the nature. We need to use all the senses. We need to give all the people the same possibilities to enrich their lives and to reach their dreams. So, I am sure that the future is completely bright and the technology will help us to permit the people to make science even with a different kind of perception about the nature.
Okay. Is there any questions? Arkadaşlar başka soru var mı arkadaşlar? Biz soralım eğer yoksa. Gökçe'cim, Sude'cim.
Yok hocam. Yok.
Okay, Wanda, can you...
Çağrı Artan sordu şimdi el kaldırdı.
Kim?
Çağrı Artan.
Çağrı'cım buyursunlar.
Merhaba. Öncelikle bütün katılımcılara çok teşekkür ediyorum bizimle oldukları için. Önemli bir şeyi konuşuyoruz burada. Dünya üzerinde çok eşi benzeri olmayan. Şimdi benim özellikle bu dörtlüye, yani aramızda olanlardan kopanlar da oldu. Oradaki doğal bir takım olaylardan kaynaklı.
Massimiliano ayrıldı. Biraz önce gitmem gerekiyor dedi chat'e galiba, yaptı mı Gökçe?
Yes. Çünkü
Beatrice-
toplantısı vardı.
Evet.
Sonraki toplantısı vardı. O yüzden gitmek zorunda kaldı. Massimiliano has another presentation now. I had other meeting, so he left. So we can ask questions to 3 people or 2 people because Beatrice has a storm, you know.
But Francisco and
Francesca and Wanda are here, my friend.
Beatrice
And
hala.
Beatrice is still here, but there is a big noise there. So maybe it's not possible to respond to your questions properly.
Tamam, Çağrı sen devam et.
Sorun değil. Yani alabileceğimiz kişi kimse ondan alırız.
Tamam.
Yani sesleri duyduğumda ben bir kör olarak bunca sesin gerçekten ayırdığına varılabildiği ve gerçekten galaksi ölçümleri, yerçekimsel bir takım ölçümler yapıldığında çok tek düzey gibi geliyor bana sesler. Hani bunların arasından doğru sonuçları elde etme konusunda ne kadar zaman harcadılar ve bunu sağlamasını yaptılar mı mesela farklı meslektaşlarıyla şu veri şu kadar kuvvet aldı gibi, yani bilmediğim için terimleri konuşamıyorum ama sonuç itibariyle ölçümlerinin farklı meslektaşları tarafından da doğru algılandığına ve seslerin onlara verdiği referansların doğru ölçümleri verdiğine yönelik teyitler aldılar mı? Onu sormak istedim. Teşekkür ederim.
Here is very interesting questions. Yes, Engin, please help me.
Okay, Wanda, the question is, Çağrı says that, yeah, you listen some sounds to us, okay, but it comes to me, Çağrı says, it comes to me that they are very similar to each other. There are some like a unique. How can you discriminate all of them, and how much time could you spend did you spend to discriminate those
To
sounds?
confirm
The
this,
first
to
one.
confirm your measure.
And the second one, is it really understanding sound, understanding universe, understanding the gravitation with sound? Is it really reliable? And do you have a chance to confirm it with your colleagues?
Thank you for the wonderful, the most question.
Yes.
Every single feature or signature or event or aspect that you identify that has the possibility of being nature, originated from nature, is characterized mathematically. So it means that we first check if it fits the mathematical, the modeling, right, of the data, if it fits the theoretical models. Also, we engage on discussions with our colleagues for the confirmation that the events that we are listening are real or not. Moving back from the point, right? I began from confirming. Now I'm going back to how do we get certain? Besides applying the mathematics, when I approach my listening to the data, one of the things that I do is that I get to know, and this is very difficult to do, right? I get, and when I say very difficult, right, is that it is time consuming. I get to familiarize myself with the data without any kind of signatures, for example, different kind of noises, white noise, brown noise, etc. And I get familiar, and I also get familiarized with the local conditions of my device, of my satellite. Once I get familiarized with that, what I do is that I calibrate my ear. In terms of the other part of your question, which is how long do I invest?
Mm-hmm.
It takes for one that it takes a very very long time, because the development of sound perception techniques has been very paused. It means it has been very, very, very, very slow, because the perceptual minority that was performing in science was sighted. So techniques to listen to the data were not developed. It takes a long while to listen to thousands of data points. Sometimes it's millions of data points.
Yeah.
So there are techniques that we use, which is to bin the data to, for example, it takes small chunks of the data overlapping the next chunk of the data by an amount of points. So I can, you can establish a continuidad. I may need to translate that word, but like a progress. I'm translating the continuity. So you can establish a continuity, right?
Mm-hmm.
So those training techniques is something that we have to experiment with and document it. So people like you, which I sure hope that you get to contribute with Massimiliano, Beatrice, and Francesco. So people like you can get started with the analysis of the data. It's not me giving you the sounds that I think have something important. Is for you to sit down and explore the sound. But right now is a little bit time consuming, and because it doesn't have any harmonic expectation, it's not like listening to a song. So it doesn't have any harmonic expectation. You're not following rhythms and clapping, and no. It's completely different to that. It requires a lot of interest, right? Because I'm engaged and I have the interest. I carry it. I carry it, but once I listen to a data to one data set once and I finish analyzing it, if you play it again to me, I may get really angry because it doesn't have any harmonic expectation.
Yeah.
And so the exploration, attention modalities in exploration is one thing, but the other thing is attention modalities when I know there is nothing new to expect in the data. So yes, it doesn't have that thing that music has that keeps you paying attention to it. I apologize. Forgive me.
Okay.
Bir soru daha var galiba Sevda. Sanki kim kaldırdı?
Evet, Elif Ünver Çırpan kaldırdı.
Tamam, alalım o zaman. Elif'ciğim.
I wish you could help us to develop the training.
Of course.
Of course. If you wish, we can cooperate.
Yeah, we can cooperate, yeah.
Thank you.
Okay. So we have another question, Wanda, coming from Elif. You know, you.
Buradan duyuluyorum sanırım.
Evet, gayet net.
Elif, yes, we met at the beginning.
Hello. Bu sesli verileri sadece körler mi kullanıyor? Gören bilim insanları da kullanıyor mu? Kullanmaları için uygun mu? Yoksa görsel datalar her koşulda daha mı kolay analiz edilebilir durumda?
Wanda, can these voices be used only blind people or sighted people?
What a good question.
Yeah.
That question is very good. Our experiments, and sorry, Beatrice and Francesco, that I'm taking this question too, on purpose. Our experiments were done with sighted astronomers that were performing at an aspect of expertise. And as I said, our results showed that for people that are sighted at an aspect of expertise, sound increases their sensitivity to events in the data that by nature are blind to the eye. So it's not only for the blind or visually impaired, it's for everyone.
Very important.
Can you say that it is also valid valid for sighted people, and also it's very reliable also related when we compare to the visual materials, right?
If you when you use the two, you increase the chances, right? Because the reliability has also to do with error analysis, which for us is also a statistical analysis. It increases the chances that the signature that you're detecting is real, especially if the signature is very small, is very dim, and is very hidden in noise. In terms of error analysis, one of the things that that I wish and I dream to achieve with the training at the European Gravitational Observatory is to be able, as sound also allows us to do a causality analysis of the data, for us to be able, and this is only a dream that I have, and I really hope that you can, with your sincerity, Turkey can join us. Yes, this is what it takes on developing an error analysis of the
for example,
of it. Yes.
Wanda, I'm so sorry. For example, you are looking the same data together. You are using the voice, your friend using the visual material. In order to be sure, your friend can ask Wanda, I'm not sure my measures. Could you please check it voice? I'm really curious about it.
It has happened. It has happened. That, for example, once I was in this observatory, right? And this friend was he didn't get anything from the data, right? And I told him there are some signatures randomly happening in the data. And can you play back, right? And it was that he was not he was making sense of the data only visually, and I was listening to the data. Once I pointed and he was able to hear, then he was able to characterize the events. Those were the ones that I presented in the TED Talk, which were resonances, exchanges between particles and waves that we were able to present. So yes, it does happen. As well as they like to. They are obsessed on being able to see what we hear. And sometimes I tell them, excuse me, but I have to take by faith what you're describing to me. So sometimes you need just to believe. And I mean, I show them, right? I play the sounds to them with the graphs, and then we characterize it mathematically. But yes, we need to get to that point of trust.
Yeah, of course.
Forgive me.
Okay, that's okay. Arkadaşlar başka soru var mı?
Evet var. Seçil Arıkan önce el kaldırdı. Daha sonra da Mürşidi Ciğerli oldu.
Alalım. Seçildim. Beatrice, sorry, could you please turn on your mic? Beatrice'in mikrofonunu. Evet, thank you Gökçe. Seçilcim, buyursunlar.
Merhabalar herkese, iyi akşamlar. Ben teşekkür ediyorum. Enteresan bir konu, fakat biraz içinde kaybolduğumu da itiraf edeyim konunun kendisinin.
Zor bir konu, evet.
Çok zor bir konu gerçekten. Bize çok yabancı gelen, hayalini bile kuramadığımız bir konu Seçil. Evet.
Ya, evet. Bir de sonuçta hani hep daha çok pozitif bilimlere yakınlık, uzaklıkla da ilgili belki onun. Ben şeyi anlayamadım. Çok ilgimi çekti ama bir türlü kafamda bir yere oturtamadım. Bunu da nasıl soracağımı beraber karar verelim. Bu Vatandaş Bilim İnsanları projesinde web sitesine yüklü yani verili dataların ses haline, ses dosyasına çevrilmiş halleri yüklü ve insanlara bu ses dosyalarını dinleyin ve bir şeye göre gene web sitesinde belirtilmiş bir şeye göre sınıflandırın türü bir uygulama mı yapacaklar? Yani oradaki bizim o sesleri dinlememizin etkisinin ne olacağını, yani biz vatandaş bilim adamı, bilim insanı olarak anlayamadım.
Okay. Let me try to translate the question. Wanda, she says that actually it's very strange issue for us, and a little bit I lost in the issue. So I want to confirm some information for me. Francesco mentioned about the website. What is the content of the website? You said there are some voices here. The voices are accumulated from the different areas, different atmospheres. What do you wait for us in order to make analysis, in order to input information to you, or you are waiting different things, or what is your criteria? What is your parameter for the evaluation process?
To evaluate you mean to evaluate the webpage of Francesco?
Yes, of course.
Okay, there are two ways that you may I think that you may engage in the development, right? One is that we are trying to develop a training paradigm, and the attention mechanisms, the effectiveness of the training paradigm has to be tested. And one of the ways these tools that we are developing are for education. Beatrice program, Rainforest program, is used for education and also for professional performance. We do not separate in hierarchies, right? Or in levels. So one of the things that we need to test is, for example, what timbres are effective. What are timbres and amplitudes, etc., are most effective for the analysis of the data? What combination of attention modalities may hinder the data? One of the things, the data analysis, one of the signal identification, one of the things that there is no clue about is the effect of the use of sonification for the learning of mathematics in the schools. So the students, they develop a multisensorial culture since school, right? Because it's very difficult to do a transition. So in all of those aspects of, for example, participating of the experiments, not only as volunteers for the experiments, but we perform experiments with people in Turkey, with schools and professionals, and we sit together as an organization and we study the data. And we so all of that, the development of the web pages, that is another aspect. It needs very strict user-centered design, and WCAG is only WCAG is just a beginning. It's just a starting point, because I'm blind, but I also have other disabilities, right? So there is comorbid aspects that have to be taken in consideration, that WCAG segregated. So in all of those aspects, is if this answers your question, is aspects that I wish organizations gathering, serving peoples with disabilities to get involved. Not, as I said, not only as doing the experiments, but for you to protagonize. And we will work hand in hand with you. There is no way we will. Yes. Sorry.
So Wanda, regarding website again, there are some knowledge in it, classified knowledge or non-classified? I mean, is there a category in the website regarding information, different voices?
Categories different regarding different sounds.
Yes. Okay.
A web page that is alive right now that you can go and access today is non-existent. I know that the Sono Uno is trying to provide for you to be able to use different timbres. I don't know when that will be ready, so you can use different instruments to listen to your data. I know it has different mappings, but I do not know when that will be ready. Unfortunately, there is the program that is the prototype that is available that offers for different sound timbres to be available. It's a program that I made myself, and it's very old. It's like so old that when people download it, sometimes it doesn't want to run because it's old and it hasn't been kept. But I know that it's the only one that I know that will allow you to use your attention mechanisms that is being prepared for that is the Sono Uno, that is respectfully being prepared for that. It will be that web page that will be user-centered. Yes, forgive me.
Okay. Before passing new question, Faruk'cum, if you like, we can change translator. Şebnemcim. Okay. So Mürşit'cim sen soru soracaktın. Sorabilirsin istersen. Gökçe'cim, Mürşit'in mikrofonu açık mı?
Sevda.
Evet, duyuyoruz canım.
Ben de Sıçı'yla aynı soruyu soracaktım aslında. Aldım cevabını. Teşekkür ederim.
Mustafa Doğuş galiba var.
Mustafa Bey buyurun lütfen. Hoş geldiniz.
Merhaba, sesim geliyor mu?
Gayet güzel geliyor. Buyursunlar.
Hello everyone. Let me continue in English.
Of course.
First of all, thanks to Wanda and her colleagues. And of course, thanks to Engelsiz Erişim Derneği and White Gate Festival team. I'm wondering if there are any other solutions except sounding, such as haptic engines or vibrating any other stuff, or AI and AR technologies. Thank you.
Very good.
So, Wanda, did you hear the questions, or if you like, we can.
Yes, I heard. Beatrice, do you want to take that one?
Yes, Beatrice, please. Are you safe, Beatrice?
Beatrice burada mı hala?
Beatrice hala burada mı Gökçe'cim bu arada? Mikrofonunu açabiliriz eğer buradaysan.
Sanki gitti.
Is Beatrice here?
Duymayı şunu göremedim.
Wanda, I think Beatrice
okay.
had to leave.
Okay, forgive me then. There is
a hurricane in that Argentina. I think it was very loud.
There is a prefabricated sound and haptics for eclipses, which is prefabricated, right? Which is it gives you the impression that you're touching areas of the sun that are not eclipsed, in the areas of space that are dark. For data analysis, when we did our experiments, our results showed that using vibration was not as effective, right? But we need to do more experiments, and perhaps that is something that your country will like to be involved on, supporting us creating perhaps a mobile platform for people to use touch interaction, haptic interaction, in order to explore the data. But before we create the application, we need to work on attention modalities. Is it effective? When is it effective? When is not effective? So we can give the user in the small modality that is the mobile interaction, we can give them something that will be of use. That is my proposal, right? And it's a proposal that we can bring to Rainforce for them to evaluate it, and or we can start working on it by ourselves.
So Engin has a question.
Actually, Wanda, I have two questions. The first one is, how much the percentage of visual data can be converted into sound with an understandable way? Or is it possible to convert all visual data to sound with understandable? The first one is that. The second one, if I, a student, want to go to a physics or astrophysics, or a blind student want to become astronaut, study astronomy, what kind of recommendation could you have to him or her to make such kind of things? And what kind of accessible solution can he or she look for?
Thank you, Engin. Thank you so much. And for as long as the data is a measurement, which is what the telescopes acquire, and then we convert it into something that is visual. We convert it into magnificent images. For as long as the data is a measurement, it can be translated into audio. Reliably, regardless of how big or small the measurement is. What Beatrice sonification prototype does is that it assigns the data into a floating number, which it means that it doesn't have an accepted. It means that it can be very, very, very, very, very, very big, or very, very, very, very small. So that is.
Let me confirm what you are saying. You said
Yes.
that. Is it true or not? Everything coming from a telescope can be converted also sound in addition to vision?
If it is a measurement, yes.
Yeah.
If it is a picture, for example, someone takes a camera. Like the Hubble, it takes a camera, it takes an image, then we can use aspects of pixelization in order to convert that into audio. That is one. For the second question, which is what you kindly brought, which is also very, very important. All your questions have been of utmost importance. For your second question, for students that are blind, that want to go to physics, I invite them to start using multisensorial exploration of the data, to tell your teachers to please use multisensorial exploration of data, even embossing the data via touch. And together with, as you touch the data, if you're sensitive to touch, listen to the data real time, using the prototypes that are available right now. Also, master the mathematics, because one of the things that we do is that we have to theoretically. We have to develop the mathematics. We have to work the mathematical equations, right? And then after we have the theory, then we do our observations. we gather our data, and then we search for the signatures. So to master the mathematics, the expansion of all of the mathematics and work it out, what I do is that I take my stylus and I work my mathematics using Nemeth. So it may sound like old school, but I also take my students and I make them work the mathematics using the stylus. For the trigonometry, which is of utmost importance, there is a 3-dimensional Cartesian plane that you can use. It's very easy to develop, and it may cost about $7 to build one in your own home. I can send you the instructions, because you need to map the direction of the force or the energy, and also you need to map the how intense the magnitude of that energy or those forces. And that is my advice is for you to get started mastering the mathematics and the trigonometry, and supporting your teachers to, when they are explaining the mathematics, to simplify the explanation of the mathematics, but to preserve the content. For example, I gave you the example of a pressure cooker when we were talking about the stars and how they go into become a red giant. So all of that knowledge is knowledge that we have made too complex, that we use very complex words to explain it, but it's a knowledge that can be simplified, preserving all the content. And that is I think that a person that really masters what he or she is talking about will know how to simplify the content, will know how to simplify the explanation, preserving the content. So books can be Braille printed, the mathematics can be Braille printed, and the explanations of the images in the books, your teacher has to find ways to convey it in multi-sensorial ways that you can contextualize to your own learning styles. Sorry. Forgive me.
Okay. Okay, arkadaşlar başka soru var mı bu arada? Yoksa benim 2 sorum olacak çünkü. Gökçe.
Hayır, yok.
Tamam. Okay. Wanda, I have 2 important questions. The first one, before presentation, we were talking about this issue among Engin. Is astronomy related to earthquake, for example, some vibration, some earthquake issues? For example, can you use this voice? Can you get information by using this sound about the earthquake, by vibration, to understand earthquake issues?
They have been using it for a long time, Engin.
Oh.
They have been using sonification for, it's called, the word is not coming to me now, but for geology, yes.
Geology, yeah, geology.
For earthquakes, and also in medicine, for the study of electrocardiograms and electroencephalograms. They have been using sonification and audification of the data, which is to directly translate a data waveform to the audible domain. It's a very good question. They use it often in geology. Yes, forgive me. In geology, they use it often Engin, and they use it because the events are so sometimes the precursors of the precursor of an earthquake is very, very, very tiny, and we need to develop ways to predict when an earthquake will happen, right? So their guess is that is more possible to detect the precursor, so we can predict when an earthquake will happen. But we need the training, which is what I wish Turkey to collaborate with.
Yes, you know, maybe you know, Wanda, we are in earthquake area as a country. So I'm curious about, do you know any blind people, any blind person who is specialized on earthquake issues in Europe or in USA?
In geology, I will have to ask around. Yes, because we had a scientist who retired. Yeah. In the United States, we had a scientist. He also Dr. Vera Blatner, who were working on geology, and they both retired. And when I approached them, they said, no, we are taking care of our grandchildren, and we are done. We are already done. So let me ask if someone else with disabilities took the baton. And if no one has taken the baton with disabilities, I think that if you have the interest, it's a subject that I know astroseismologists. The astroseismologist that I know that is working on using audio and tactile exploration, she's in Belgium. And, now this is on the stars, right? But I may get her in touch with you in order to continue exploring ways to continue analyzing the data. Her name is Katrin Kohlenberg.
Yes.
So I can get her in touch with you. She's a very good friend of mine.
Yeah, I will be happy. Wanda, my second question is about tactile issues. I mean, can you also use tactile materials other than voices in your research to get knowledge, objective knowledge?
To use it real time as I use it. I do not have any experimental evidence of its effectiveness, right? We need to create the perceptual evidence. But for example, to print planets three-dimensionally, to print images three-dimensionally, there is most of the people, what they do in order to familiarize blind, visually impaired and blind learners with the data. What they do is that they print three-dimensional images of what the astronomers display visually. That yes, do exist. And many people do it. My focus is to be able to use the combination of visual, audio, and tactile together in order to learn the mathematics, explore the information, and progress to mainstream in the field. One of the things that we humans do is that we use multisensorial combination in order to navigate in real world. In order to people smell, they look at it. It looks nice. Then they smell. It doesn't smell that good, so I'm not gonna touch it.
Yeah, of course.
Does that make sense? We on daily basis we explore multisensorially, and it's my big wish, right? That we can after this White Cane conference, we can sit down together and think, how can we can we move that forward? Because we need to do the experiments, develop platforms that will be effective for the people and that will be inclusive. Yes, sorry, forgive me.
Maybe after the pandemic you can come here and you can show you can demonstrate all your materials to people. Maybe.
Or you can come to Italy, or I can send you it to Italy. That would be great if you do. Yes. We can go to the Zero conference and present together.
Arkadaşlar başka soru var mı bu arada?
Hocam hala Nurşide Ciğerlioğlu ve Elif Enver Çıkan'ın elleri havada kalmış ama...
Hayır, ben indirip geri kaldırdım. O yüzden havada.
Ha, tamam. O zaman sizin var.
We have other question, Wanda. Elif. Again, Elif.
Şimdi şey sormak istiyorum. Aslında erişilebilirlik dışında bir soru sormak istiyorum. Daha çok sanki yıldızların kütle çekimine ulaşabildiğimizle ilgili bir anladım.
Falan şeyler yapmışlar daha çok. Onları anlamak için.
Ne?
Kara delikler falan hani.
Kara delikler. Peki bu veriler bize şeyi de sağlıyor mu? Yani kütle çekimiyle ilgili veriler bize işte daha küçük gök cisimlerinin verilerini de sağlıyor mu ve mesela uzaklık konusunda bilgi edinebiliyor muyuz? Ya da işte bu gök cisimlerinin işte element içerikleriyle ilgili hangi şeyi sağlıyor? İşte hani hep bir de yaşam var mıdır? Onu araştırır diye biliyoruz işte astronomi alanı, hani nerede yaşam vardır bunu araştırmaya yöneliyormuş gibi bir algımız var bizim sıradan vatandaşlar olarak. Dolayısıyla hani bu element içerikleri bir o gök cisminin özellikleriyle ilgili bize hangi verileri sağlıyor? Çok mu büyük bir soru sordum acaba?
Elif has a interesting question and very complicated question, Wanda. We are trying to translate. Faruk sen bize yardımcı olabilir misin?
Ben de çeviririm ya.
Daha güzel çevirir anlamında.
Şimdi onu geri al koy bayağı.
Okay.
I'm very interested in the question.
Wanda, the
Yes.
question is, as we see that we are taking information from the stars, from the things, objects, particles from the space. Is it true? Okay. From that, Elif is asking, what kind of data can we get with sonification? Only what is only the gravitation, or can we also take information about the elemental structure of that, or distance, how much distance is far away from here, or is there any life in that position or not? What kind of information can we get from that sonification?
Very good question. Thank you so much, Elif, and to all of you for all of your wonderful questions. Today we presented gravitational data, and I presented emissions of energy from the sun. When particles are moving, they generate magnetic fields. So also we can listen to magnetic fields, we can listen to temperatures, we can listen to velocity of different particles, cosmic rays. We can listen to light curves in the telescopes, right? What they are monitoring is intensities of lights and events that happen because of changes in those intensities of light, what that light is being modulated by, or so all of that you get it from different measurements, velocities of electrons, densities of different elements, ion composition in different parts of the space within the planets. All of that you are able to plot it, print it, emboss it, and convert it into sound. In the case of my exploration, what I do get from listening to this modulation, right? You can get a lot of information. For example, the mass of an element in what mass of hydrogen there is in this galaxy. You can determine that by listening to the data. And if next year we don't have the pandemic, we can do a one day when we show you how we can listen to different to the emission line of hydrogen in a galaxy, and how we can determine using audio the mass of hydrogen in a galaxy. For example, in a spiral galaxy. On the same way, we listen, for example.
Şebnem, translator.
Forgive me, but we can listen to a lot of things. Yes, yes.
Okay. Ben bir an sanki yok gitti diye düşündüm de. Tamam. Okay. I'm so sorry. Okay.
Okay.
Yeah.
Duyuyorsunuz değil mi translation arkadaşlar? Bir sorun var mı?
Sanki bir şey geldi de tamam. Yes, you can go on, please.
Bir dakika, biz gittik.
Okay, you can do all the science. You can do all the science a sighted scientist does. What we found is that we can find more things that they were ignored because they were not seeing it.
Yeah.
That is humbly what we found.
I will ask such kind of thing. Maybe lastly, Wanda, you said that by listening, and if you know how to listen, what to listen,
yes,
as you said, you can take many data from the velocity, from magnetic, from these many things. And can we conclude that if you are a totally blind person who likes using sound in your life very much, very frequent, and utilizing sound from your life, could this be an advantage for you to choose interested in such kind of scientific area?
Yes, indeed. And not only if you like to use sound, right? Some people are not auditorily oriented, because when we start reading, for example, as someone that is congenitally blind, we teach the person to focus on touch and interpretation by touch, right? We don't focus the attention modalities of the people to be multisensorial. But if we develop the training, which is what we desperately need, if we develop the training, so multisensoriality is used from school time, then it may be used for anyone. And if developing the skill, then you will be able to freely choose, Engin. If you want to be a scientist based on interest and not based on obstacles. I know I want to be a scientist, but I cannot do it because it's too difficult, because I will not be able to explore the data. No, you will choose because of interest, because I can touch, I can hear, and we need to develop the experiments. Did I answer your question? I apologize.
I asked that question because, Wanda, maybe in most of the times, as like every field of the life,
yes,
in science also, the superiority of visual material, sightedness is imposed on us, and they think that other things are not necessary. But your speech is very valuable in terms of that, because you said that multisensoriality is important, and sometimes sound might give us better data than
visual materials.
Do I understand it correctly or not?
Yes, you are all understanding it correctly. Our experiments are published in my dissertation. So people can go there and, mira, Engin, you are completely right. One of the, when we got my results to my experiments, I got depressed. I got really depressed because I thought these people left me out just because they wanted. I can't believe. That and then my mentor said, not only they left you out, but they have lost a lot of information. They, you know, the discoveries they have missed because they haven't used multisensorial perception. So in that way, that empowered me to say, okay, this is for all of us. It's not only about me. They also were affecting themselves by not using sound. So yes, multisensorial perception is it enriches data analysis for everyone. There is a lot of work that we have to do together. Like the trainings, like bringing the teachers on board, breaking social stigmas. For example, sometimes the teachers do assume, they do it unwittingly. Teachers are very good, but they do assume that there are things that we cannot do.
Yeah.
And it's not bad, right? They sometimes they try to do it to protect us, right? But yes. But we need to, by working together, is that we defeat those those social ideas that or if we come to science, it's only to do education and people outreach, which is very important. But I come to science to be an explorer, to be a scientist.
Wanda,
Yes. Sorry.
is there any question? Arkadaşlar başka soru var mı?
Elif Ünver Çıpan'ın ya eli havada kaldı yine ya da sorusu var. Bir tek o var.
Elif'ciğim sorun var mı? Yoksa kaldım havada?
Havada kaldı sanırım.
Tamam.
Ama çok teşekkür ettiğimi söylemek zorundayım.
Söyleyeceğim.
Okey. Başka soru var mı? Ben bir şeyler daha söyleyeceğim. Sonra yavaş yavaş kapatalım. Başka soru var mı Gökçe'cim?
Yok, başka yok.
Okey.
Ya şu an Mürşide Ciğerlioğlu kaldırdı.
Gökçe'cim, sorun var mı canım?
Sevda?
Evet, duyuyorum hayatım.
Ya ben kaçırdım mı bu görsel veri sesi nasıl çeviriyorlar? Yani hani bu kolay bir şey mi? Az önceki konuşmada tüm görselin sesi çevrilebileceği diye bir şey anladım ben. Ama programın başında bundan bahsedildi mi? Ben mi kaçırdım ya da bu çok değinilmedi mi bu konuya? Şimdi onu merak etmeye başladım.
We can ask one more time again. Wanda, how can you convert visual material to the voice?
Sound.
Sound.
Which kind of technology are
What
you
kind
using?
of technology are you using?
Okay, so I use the Sono 1 that Beatrice created, and I use a prototype.
Yeah.
And I use a prototype that I created long before Beatrice, that is the Xonify. But the Xonify, what I do is that I bring the data from the databases, or any kind of 2 rows of numbers, right? It may be a multiplication table or anything. And the program does a literal translation of all of the measurements into the audio equivalent. And then the Xonify allows you to use different timbres in order for you to listen to the data. If I want to use a drum, a drum is a membrane, and I can, for example, use the mathematical model of a wave moving along on top of a membrane in order to listen to my sound. And then sometimes I use the Sono 1 prototype of Beatrice if I do not need to use different timbres in order to draw my waves. But the Sono 1 is much better than the Xonify. The Xonify is so old. I'm embarrassed because it's so old. The
Sono 1, it is like
Sono
in Italian.
Uno.
It is a new product.
The Sono 1 is a new product. I can send you the link to it. The web page is supposed to be finished soon. Okay. And I can send you, I'm writing to Beatrice right now because she's asking me, because she had to disconnect because the water level in her house went over I think 4 inches. So she had
Well,
to.
hello, light.
But I can send you the link to the Sono Uno.
Of course.
Hello, friends.
Adiós, Beatriz está ahí. Beatriz is there.
I am saying, no, it's okay, but was a disaster, complete disaster in my house. And well, the light was cut, and well, yes, the water went 10 centimeters, 3 inches inside my house.
And you are still here.
And well, what a disaster. I have a very beautiful garden. No, it's not like this. I didn't have a beautiful garden. Yes, it's all destroyed. But well, it's the weather, it's the nature finally.
Very, very. Get well soon, Beatriz. I hope you're okay. Your voice is coming very, very good to hear.
No, Wanda told me that you are interested to explore the data. Is that right?
Yes.
Well, we need volunteers, so it's a good association you want, and we need. So the idea is to share the development and try to have more users and collect more answers and more ideas. And of course, we have different kind and levels of activities and courses and training programs, even with very simple data, as the data that you can use in the school, primary school. For example, we have some trainings with using a linear regression or a circle or a parable or an ellipse. So the idea is to make the approach to the knowledge, the mathematics, physics, and after that, the stars, following a road for the simplest experience to the complex one. So if you want, we can make a very, very virtuous association.
Okay, thank you Beatriz. So, arkadaşlar başka soru var mı? Yoksa yavaş yavaş toparlayacağım çünkü. Var mı?
Yani yine el havada kalmış olabilir Elif Ünver Çırpan ama diğer yok başka türlü.
Okay, Wanda. First of all, thank you for your wonderful and fantastic presentation. You are very inspiring us for the future. But before finishing our session, what would you like to say to young people, young students, in order to make career on astrophysics? For example, is it possible for me to apply to the astronomy department for next year for any university for me, for example? What would you like to say?
Well, Sevda, if it is you, apply to where I am. Because I will take you everywhere. Yes, I mean, keep on hanging. I will take you everywhere. I think that as Beatriz said, and before we I answered your question, is that perhaps Beatriz, let's design or let's enrich, if you may, your workshop together with Engin and Sevda and the team with a multisensorial perception of data analysis, to take real data and analyze it. If you think we can engage on doing that, and perhaps do a workshop, maybe online. But this is just an idea I'm throwing there. Just it came to me.
Yes,
but let's do it. Let's focus on that, because we need to finish that book that you proposed. But to the Sevda, I think that with the changes that are happening right now, right, it's very, very, very possible for people's with any kinds of disabilities to find first good mentors that will support them, like as it happened to me. And that's why I began talking about my personal experience. I was lucky because I found a good mentor. Now the mentors are online, digitally. You can find a good mentor, right? That will support you acquiring the necessary skills, just as we are. We don't need to change anything. We learn just as we are in order to be able to perform in the field. I always tell people that people that succeed, or people that are how you say great? No, outstanding. People that are outstanding. I call people outstanding people that do not give up. People who win in life is people that do not give up. And the people that are outstanding is people that discipline themselves, that conquer their minds and social stigmas. And like warriors, they continue moving forward, transforming obstacles into opportunities until they become victorious in lives. So the only thing I say is that I want to encourage you to continue with your strong will. If you continue with strong will, even if people tells you comments like you cannot do it, or we don't want you to come here anymore, just continue with your strong will, with the determination to win. That people's doing those comments, those are people with primitive minds, people that haven't evolved with the ecological times we are living right now. You know me, you know Massimiliano, you know Beatriz, right? You have us in your network. You have people you can come into, and we come to you because we want to stretch a human relationship with you, not because we are searching for public relations. We want to become brothers and sisters in the pursuit of equal participation. So I encourage you to continue with strong will. Let's start working on this workshop tonight. Let's give a lot of work to Beatriz to perform, and let's continue working together. And remember, to win is not to give up.
Okay, this is the beginning. This is the beginning work for us. Wanda, thank you for your participation, for your wonderful and fantastic presentation. I hope we will see each other, I don't know, maybe a few months later, or 1 year later, I don't know, but I'm very happy to hear your voice and to get information about astronomy and science and accessibility, and your views on accessibility, equal conditions. It's very, very important issue for us and for our country. Thank you for your contribution, and thank you for your fantastic presentation. Have a good one. Have a good luck, and good night to you. No, not good night to you. Have a good lunch to you. If you like, we can meet and we can go together lunch. I will invite you. Okay.
Okay. Thank you so much. Thank you, Beatriz. Thank you so much.
Thank you all. Yes, thank you very much. I'm so sorry. So sorry to because there was a weather would
no.
have the connection. Sorry.
Beatriz, take care of you. Please be safe. Okay.
Yes, I am. Thank you. Thank you very much.
Okay. Thank you so much. Thank you.
Bye.
Bye.
Okay. We can stop.